Hello! Welcome to today's lesson on understanding acceleration as a vector quantity. Today, we'll start by understanding acceleration as a measure of the rate of change of velocity over time. Next, we'll consider how acceleration, like velocity, is a vector quantity. We will expand on what this means for how we understand positive and negative decelerations. So far, you've become familiar with speed and velocity, understanding that speed is a scalar quantity and velocity is a vector quantity. You now know the importance of direction when dealing with vectors. Building on this foundation, we can now dive deeper into acceleration as a vector quantity. Let's get started.
So what is acceleration?
Acceleration is the rate at which an object's velocity changes over time. This means it describes how quickly the object speeds up, slows down, or changes direction. You can think of acceleration as telling you how fast the speed and direction is changing every second. For example, if you are riding a bicycle and you start pedaling faster, you're accelerating. If you start applying the brakes, causing you to slow down, you're still accelerating, just in the opposite direction. Remember from our previous lesson that a velocity time graph shows us how the speed of an object changes over time. The steepness, or slope of the line on this graph, tells us about the object's acceleration, which is the change in velocity over the change in time. If the line slopes upwards, the object is speeding up. If the line slopes downwards, the object is slowing down. A steeper line means greater acceleration. Now let's go deeper into the fact that acceleration is a vector. This means it has both a magnitude, how much, and a direction. Suppose you are driving a car north and you press the gas pedal. Your acceleration is directed north because you are speeding up in that direction. Conversely, if you press the brake pedal, your acceleration points to the south because you are slowing down while still moving north. Thus, the direction of the acceleration vector changes depending on whether you speed up or slow down, and depending on the direction of your velocity. Let's consider a couple of real-world examples to help us see this more clearly. Imagine a bus initially at rest starts to move forward and increases its speed at a rate of 2 meters per second squared. This is positive acceleration directed forward. Now think of the same bus when it is moving at a speed of 10 meters per second and starts to slow down at a rate of 2 meters per second squared. This would be negative acceleration, deceleration, because it is directed opposite to the motion of the bus. So, if we say an object has an acceleration of minus 2 meters per second squared, this means it is slowing down at a rate of 2 meters per second every second in the direction opposite to its current motion. It's essential to understand that the sign of the acceleration indicates its direction relative to the current motion. Positive acceleration means the object is speeding up in the current direction of motion. Negative acceleration, or deceleration, means the object is slowing down. If we say an object has an acceleration of minus 2 meters per second squared, this means it is slowing down at a rate of 2 meters per second every second in the direction opposite to its current motion. In today's lesson, we delved into understanding acceleration as a vector quantity. We began by defining acceleration as the rate at which an object's velocity changes over time, describing how it can involve speeding up, slowing down, or changing direction. We explored how acceleration appears on a velocity time graph, noting that the slope indicates acceleration. We emphasized that acceleration is a vector, meaning it has both magnitude and direction. This foundational understanding sets the stage for more advanced studies in forces and motion. Watch the rest of the GCSE physics course at Sophos Education.